Good morning, afternoon, or evening. How you all doing today? Welcome back to Mr. Morrow's intensive math class. Today we're going to talk about rational numbers. And the good news is that we've already learned about rational numbers earlier in the year. But we're going to revisit it and we're going to make sure that it's very solid with us because we work with rational numbers quite often. Now, in order to really be able to work with rational numbers, you have to know what rational numbers are. And rational numbers is basically a number that can be written in A over B or in a fraction form. If you could write a number as a fraction, it is called a rational number. So what does this include? Well, rational numbers include natural numbers, and natural numbers are numbers that are greater than or equal to 1, but they're whole units. So natural numbers are things like 1, 2, 3, 4, 5, 6, 7, 8. Natural numbers, if you guys remember, are also called counting numbers. Rational numbers include whole numbers like 0, 5, 12, 15, 19. How do you write those as a fraction, Mr. Morrow? Some people may ask. Well, the number 18 has an invisible denominator of 1. So if I can write a number as a fraction, it is a rational number. Of course, all fractions and mixed numbers are rational numbers. Repeating decimals are rational numbers. Terminating decimals are rational numbers. And last but not least, perfect squares. Okay? Perfect squares such as square root of 9, square root of 121, square root of 64. All of these are perfect squares, and perfect squares are rational numbers. So again, a rational number is any number that can be written in fraction form, in A over B form. They include natural numbers, whole numbers, fractions, mixed numbers, repeating decimals, terminating decimals, perfect squares, and missing one thing here. They also include, I apologize, integers. And remember that integers are numbers that are greater than or equal to 0, but also less than or equal to 0. And they're positive and negative whole values. So natural numbers, whole numbers, integers, fractions and mixed numbers, repeating decimals, terminating decimals, and perfect squares are all rational numbers. Okay? Please know this definition because I will quiz you on it and I will test you on it. Okay. Now, before we get into some operations with rational numbers, let's go ahead and talk about absolute value. Absolute value is the distance from 0, guys. And the absolute value symbol, which are two straight lines here like this, indicates absolute value and is treated like a parenthesis. Therefore, operations inside of the absolute value symbol must be completed first. Remember PEMDAS. Please excuse my dear Aunt Sally. Those are the order of operations. So whatever's inside of absolute value, that must be calculated first. Then that value must be taken out of the absolute value sign. But absolute value, remember, is the distance from 0. That's why absolute values are never negative. Because how can you have a negative distance? You can't. It's impossible. So whenever you have absolute value, your answer will be positive. unless it's being multiplied by a negative. Let me explain what I mean by that. For example, let's look at number 1. The absolute value of negative 3. Well, if I just finished defining absolute value as the distance from 0, let's take a look at negative 3. Negative 3 is right here. Let's look at the distance from 0. Isn't it 1, 2, 3 units away from 0? So that's why the absolute value of negative 3 is 3. What is the distance of negative 3 from 0? 3. What is the absolute value of regular old 3? Well, no, it would not be negative 3 at all. What is the distance from 3 to 0? 1, 2, 3. The absolute value of both 3 and negative 3 is 3. The absolute value of any number is always positive. Why? Because it is a distance from 0. And distances cannot be negative. How about example 3 here? This is negative times the absolute value of negative 5. Remember what we just finished talking about. Got to use order of operations here. So you first want to calculate what the value of the absolute value of negative 5 is. What is that? What's the value of absolute value of negative 5, guys? 5. But what does this negative here represent? That's a negative 1. That's an invisible negative 1 being multiplied to the absolute value of negative 5. What's the absolute value of negative 5? 5. But what's negative 1 times 5?
Negative 5.
So my answer for this one will be negative 5. Excuse me. Not because the absolute value of negative 5 is negative 5. No. The absolute value of negative 5 is 5. See, from here I went to positive 5. However, this guy right here, this negative 1, this invisible negative 1, must be multiplied to that 5. So 5 times negative 1 is negative 5. So please be aware of how to use absolute value correctly. Let's do some examples here. I got negative 3 times absolute value of negative 7 plus 5 times absolute value of negative 2. Okay. What does that absolute value of negative 7 become? Positive 7. What's the absolute value of negative 2 become? Positive 2. So this gives me negative 21 plus 10, which gives me negative 11. How? Why, Mr. Morrow? Well, I have this negative 3 times the absolute value of negative 7, which is 7, plus 5 times the absolute value of negative 2, which is 2. Negative 3 times 7 is negative 21, plus 5 times 2 is 10. That's negative 11, and you're golden. Please be aware of this, gentlemen. This is what you will be quizzed on and tested on. It is easy. Good, Papa. I'm glad you like it. It's nice and simple, but it's very powerful, very useful. The absolute value of 7 minus 12. Please remember, good job, son, that this is inside of a parenthesis. So I first have to find what this is. So inside of the absolute value, I'm going to have negative 5. It's still inside the absolute value, though. And then what's the absolute value of negative 5? 5. Very good. So my answer will be 5. But this is there's a procedure here. You got to make sure you understand the steps. Okay? Number 6. I got negative 3 times the absolute value of negative 3 minus 5 plus 12. Look at what it says here in red, please, gentlemen. Complete all operations inside of the absolute value first, then simplify from there. So, what's negative 3 minus 5 plus 12, boys? What's negative 3 minus 5, guys?
Oh, 8 minus 8.
Negative 8 plus 12
4.
is 4. So it's still in the absolute value. What's the absolute value of 4? What's the absolute value of 4? 4. Guys, whoever said negative 4, you're wrong. The absolute value of any number is positive. So that's negative 3 times 4. And then what's the answer? Negative 12. Please be careful, guys. Absolute value does not mean you switch signs. No. It is the positive value of whatever number is inside that absolute value. The absolute value of negative 7 is 7. Why? Because negative 7 is 7 units away from 0. Does that make sense, boys? Awesome. Comparing rational numbers. Comparing rational numbers. We've talked about this already as well. Luckily, this chapter should be a review of a lot of things that we've done. To compare integers, negative numbers. Remember that the larger the negative number, the smaller the value. So if I have to compare negative 100 and negative 48, negative 48 is larger, is greater than negative 100. The larger the negative number, the smaller the value. Fractions. Cross multiply and compare the cross products. The highest cross product belongs to the highest or largest fraction. So in this particular case, if I'm comparing 3/8 and 4/7, 7 times 3 is 21. 8 times 4 is 32. So that's why 4/7 is greater than 3/8. Remember that the alligator eats a large number. Decimals. Compare each place value one at a time. For example, here, I've got the 3 and the 3. They're both equal in the same place value. 2 and 2. But 8 is greater than 6. So 3 and 2,865 10,000ths is greater than 3 and 2,685 10,000ths. Okay? So all of this is review. We have seen all of this. This should be very simple. Okay, guys. And last but not least, let's compare each of these from least to greatest. Okay. Here we may have to do some simplifying here, guys. I'm going to want to go ahead and simplify all these to values that I can easily determine which is larger and which is smaller. So let's first start with, what's the square root of 16? 4. Okay, what does negative 4 and 3/5 turn into as a decimal? Negative 4.6. Remember, guys, that to go from a fraction to a decimal, you simply divide, and that'd be 6, okay? Then I have negative 4.2, and what's the square root of 81? But what's 9 times this invisible negative 1 here? Okay. So, nice and clean. Those are my answers. Now I need to list these in order from least to greatest. So who is the smallest value here, gentlemen?
4.6.
Negative 4.6.
No. Negative 9. The larger the negative, the smaller the value. And negative 9 belongs to the square root of negative 81. So negative square root of 81 is the smallest value. Done. Next, smallest value. No. Negative 4.6. Yes. Negative 4.6 is negative 4 3/5. Remember, guys, the larger the negative, the smaller the value. Papa, isn't 4.6 larger than 4.2? Isn't this a negative and not a negative? The larger the negative, the smaller the value. Who's bigger, negative 100 or negative 5? Negative 5 is larger. The larger the negative, the smaller the value. Think about it as owing money. Would you rather owe $5 or 5,000? 5. Negative 5 is greater than negative 5,000. The larger the negative, the smaller the value. Okay, let's continue. Who's next after this?
4.2.
No, there's no 4.2 here. Negative 4.2, very good. And last but not least, 4. Okay? Which is actually the square root of 16. Okay? Very important for us to know these things, guys. Any questions at all here? Going once, twice. All right, we know our rational numbers. Thank you very much. Have a great day. I hope you learned a lot. Bye-bye.